In this problem here, we'll be working with half-life, and I just wanted to do one example of that as well to help you guys review. So it says the half-life of an element is 1,690 years. If 70 grams are present now, how much will be present in 680 years? And so I wrote up on the board the equation for half-life. It's just an generic exponential equation where C and K are constants that we're going to have to solve for using the information given. T is the number of years, and then A is just going to be the final amount. Actually, we will realize that C is just the initial amount, just like in the compounded continuously formula, but let me show you how we get that. So we know 70 grams are present now. Let's call now time 0. So we would get, we would get 70 is the amount right now, C e to the k times 0. So k times 0 is 0, e to the 0 is 1, times c is still c. So we just get that 70 is equal to c. Now we can plug that back into the original equation to get one step closer to our final equation. So we get 70 e to the kt. Okay? The one other piece of information that we know is that the half-life of this element is 1,690 years. So if we plug in 1,690, we're going to get half the original amount of the element. So we start with 70 grams, so then we know we would have 35 grams after the 1,690 years. Okay? From here, it's just a matter of solving for k using some logarithms, but first we'll divide by 70 on both sides. So 35 divided by 70 is 1/2 is equal to e to the 1690k. If we take the natural log of both sides, we'll cancel out that e. So natural log of 1/2 is equal to 1690k. And if we divide both sides by 1690, we'll get k equals natural log of 1/2 over 1690. All right, if we plug that back into this equation, just like we did with the c, we'll get that a is equal to 70 e to the natural log of 1/2 over 1690 t. Okay, now we could plug 680 into this equation, or we could just simplify it a little first. If we do simplify it, we're going to get 70 e to the natural log of 1/2 to the t over 1690. Notice I just broke that exponent across, and e to the natural log of 1/2 is just 1/2. So we get 70 times 1/2 to the t over 1690, just to simplify things a little bit. So that's our most simplified equation right here. And finally, to get the amount present in 680 years, we could take 70 times 1/2 to the 680 over 1690. And if I throw that into a calculator, I will get 52.96 grams is the amount present after after 680 years.